To understand the horizontal line test, let's look at it from the perspective of a vertical line test. Here's a parabola, y equals x squared plus 5x plus 6. If I apply a vertical line test to it, you will see that the vertical line crosses the parabola at exactly 1 point during the process. As long as it crosses no more than 1 point, then I can say that the parabola is a function. But what about this graph's inverse? Remember, all graphs' inverses are a reflection with respect to the identity function, which is this line right here, y equals x. So I'm going to turn off the vertical line test, and I'm going to turn on the reflection. And you can see here by the reflection that this does not look like it's going to be a function, because if I were to apply the vertical line test to this graph, it's intersecting sometimes as many as 2 spots. In other cases, it doesn't intersect at all. But again, since it intersects more than once, and let me show it to you. Here's the vertical line. Here's the parabola, and you'll see 2 points pop up, A and B. And because of it being more than one point, this graph is not a function. This function, this not a function. I could have told you this if I would apply what was called the horizontal line test to the original graph. Let me explain by turning on the horizontal line. This horizontal line crosses this graph in 2 spots. This spot here's mirror image is right here to the B. This spot here is the A. So as I move the horizontal line up and down, move the arrow. If I move it up and down, you will see that A and B are moving along with it, and there are 2 spots here where it's crossing because of this crossing horizontally here, this being the B, this being the A. If I would go far enough down, it wouldn't even be intersecting this graph, therefore would not be intersecting this graph. So let's apply the horizontal line test to the top graph, the vertical line test to this graph, and you can see what I'm talking about. This line crosses twice, this line crosses twice, therefore this may be a function here, but the horizontal line becomes a vertical line when reflected with respect to the identity function, and therefore tells me this is not a function. When you can say that the inverse is a function as well, we call that 1-to-1. My next job is I'm going to delete the original parabola, y equals x, and I'm going to put in a new one, which is a cubic, y equals x cubed plus x. Here's the graph of that particular function. Let's just make it stand out a little bit longer. It's definitely easier to see. You can see that with the horizontal line test, what's going to go up and down, let's turn off the vertical line, it's only crossing in 1 spot. Therefore, the inverse of this graph will also be a function. To demonstrate this, remember that I don't have to use a special command called reflect. I could just type in instead, change all the y's, which in this case is f of x. I could change that to x equals, type in y cubed plus y. There would be the inverse. It's a little thinner. Change the horizontal line test to a vertical line test, and you will see now that it is also passing the vertical line test. Why? Because I could have looked at this graph here and showed you that what was crossing here was crossing here. So again, let's just do a little intersection point there and here and there. Oh, try this again. Intersect here and here and here and here, and you'll notice that where it's crossing at A, it's 1.44 comma 4.4, and here would be the inverse 4.4 comma 1.44. And as long as I move this back and forth, let's make sure I do this, you will see, let's go, come on. There we go. Passes the horizontal line test with no problem.